Hello everyone. J'aimerais vous souhaiter la bienvenue à ce webinaire. I would like to wish you a warm welcome to this webinar. A reminder that this webinar will be in English. I'm talking to you. I'm the head of the Uranus Consortium, which is based in Montreal. So that explains why I started things in French a bit, but everything's going to happen in English. Don't worry. The webinar is organized under the umbrella of INBOA. INBOA was created as a legacy project of the Adaptation Future 2023 conference that happened in Montreal in October 2023. It's the international network of boundary organization on adaptation, hence INBOA. It's a new collaborative network which aims to create a learning space for boundary organization. Boundary organization are those organizations that are working actively to facilitate exchanges between science and decision making for climate adaptation in order to advance adaptation to climate change. As a member-driven network, we hope to, by working together, we hope to share knowledge, to advocate for the model of boundary organization, which we think adds a lot of value in connecting science to decision making, and to create capacity and enhance the impacts of boundary organization working on adaptation. And obviously, we want to help to grow and increase our collective contribution to global adaptation around the world, both in the north and in the south. Uranus is currently acting as the secretariat of the INBOA network. And that's why we are hosting this webinar today. We will share a link to the INBOA website in the chat if you wish to learn a bit more about the network, about the initiative, and about how to register and become a member and in INBOA if you qualify, obviously. Before we start, a few housekeeping rules around this Zoom format of this webinar. So there is a Q&A box dedicated to write questions, so don't hesitate to type in questions at any time during the webinar, and there will be interactive moderation in the Q&A after the presentation. There will be a Q&A period during the webinar, and we will activate your microphone so that you can ask your question live. Maybe we won't have time necessarily to answer all of the questions, but we'll try to group some questions, etc., and to make it as dynamic and as relevant as possible. So today's webinar is organized by the Climate Service Center Germany, GERICS. It is a founding member of the INBOA network, and I will now hand the floor to Henry Wu from GERICS, who will be moderating the webinar. So again, thanks everyone for being here today.
Great, thanks. Good afternoon, everyone. My name is Henry Wu. I'm a scientific officer based here in Hamburg, Germany at the Climate Service Center Germany, and I will be your moderator for today. This webinar brings together 3 experts to discuss various aspects of climate service. Each panelist will present for about 15 minutes each, and we will collect questions from the audience when it is written in the Q&A box. And it could be either directed at a specific panelist or a general question for any speaker. And we will moderate this question and answer session in the final 30 minutes of our webinar today. So today we have Professor Christopher Hewitt, from the Director of the World Meteorological Organization, Climate Services Division. He will discuss climate services at the global scale and how they are being developed and implemented regionally, nationally, and across sectors like agriculture, water health, disaster risk reduction, and energy. And our second speaker today is Professor Kehinde Ogunjobi, Scientific Director of the West African Science Service Center on Climate Change and Adapted Land Use, WASCAL, Competence Center in Burkina Faso. He will be presenting the CECLIS project, which will be the focus as this initiative aims to enhance resilience and sustainable socioeconomic development in West Africa through customized climate services. And our final speaker is Professor Daniela Jakob, Director of Climate Service Center Germany. She will draw from her experience leading Climate Service Center and will emphasize the importance of co-production in climate services. highlighting sort of the iterative engagement between providers and users of climate services. And our first speaker is Professor Christopher Hewitt from WMO. Professor Hewitt joined the WMO in 2022 as the director of the Climate Service Division, collaborating with organizations worldwide to build resilience to climate variability and change. And so prior to this, he was head of the International Climate Services at the UK Met Office and a professor of climate science at the University of Southern Queensland in Australia. And he has been instrumental in developing the UN's global framework for climate services and has led several European climate service projects and co-chaired 3 WNO expert teams. So we thank Professor Hewitt for giving us his time today. And please go ahead, Professor Hewitt. Oh, you're on mute.
Good job, I checked. Can you see my opening slide in full screen mode?
Yes.
And you can hear me now. Good. Thank you. Thank you, everybody, for joining, and thank you for organizing this as well. I see lots of participants around the world, so very exciting. Yep, I will talk about climate services. I'm conscious, though, that many of you are probably not familiar with the World Meteorological Organization, so one quick slide to introduce the WMO. So it's the UN specialized agency for weather, climate and water. We have 193 member states and territories all around the world. And the main purpose is to support resilience and sustainable development of all nations, but especially the most vulnerable in the face of weather, climate and water-related events. We also set best practice and international standards for weather and climate. And fun fact, perhaps, WMO and the United Nations Environment Programme UNEP established IPCC back in 1988. And the picture on the right shows the WMO building where I'm currently sitting here in rather warm and sunny Geneva, and the IPCC Secretariat is also based on the top floor of that building. So that is WMO, but on to climate services in general. So as an example to try and illustrate and put in scope what we're talking about here, some timescales and illustrative use cases. So down the left-hand side, I've tried to break it into 3 broad timescales. And this is largely based on the climate science and the climate service provision. And then on the right-hand side is an illustration from the user side of use cases on these different timescales. So starting on the left, so at the top, the past and current climate is a key timescale for climate services. So the words in blue show the underpinning capability, the data and the information that underpins the services. So for the past and current climate, we have climate observations, climate monitoring, climatologies, reanalyses. We can go into these in the Q&A if needed. And this is then, in my view, the most important climate service. So trying to understand from the user's point of view, what is their vulnerability to current and past climate variability, climate change, whatever it might be. And also, if we then think to head to the future as a baseline for any future scenario planning. So this timescale, past and current climate, absolutely essential for climate services. But of course, we're interested in the future. Why wouldn't we be? So I've then split the future into 2 broad timescales. It could be split different ways, but based largely on the current capability we have from the climate science and the modelling. So the near-term future climate, thinking about the coming months, seasons, perhaps out to a decade into the future. And here we use monthly or seasonal forecasts, maybe out to decadal predictions. And so the data comes from these prediction systems. And then on the right, you can see a range of use cases as examples. So these timescales are of interest for people planning operations, planning resources. Market traders are very interested in these timescales, the insurance and reinsurance sectors, international development and humanitarian aid agencies, people looking at investment strategies and managing financial risks, and then regulators thinking about standards. And we start to think about adaptation strategies on these timescales as well. So that's the coming months, perhaps out to a decade into the future based on climate predictions. And then on the longer timescale, perhaps of more interest to this group, is the longer term future climate. So here we use multi-decadal climate projections. So for example, the global ones might come from the Coupled Model Intercomparison Project, CMIP, which underpins a lot of the activities in IPCC, or they might come from regional climate models, activities such as Cordex, which maybe Daniela will touch on. So we have these multi-decadal climate projections, and then the interests from the users often around mitigation policies on these very long timescales, people planning large infrastructure projects, people looking at national and international security, adaptation strategies, etc. But the diagram shows that many of the use cases, they don't particularly want to be split into these timescales. Some interests span many different timescales, and indeed often they link through to weather timescales. So at the very bottom of that diagram, people thinking about warnings and emergency response or planning for disruption or operations, they're often trying to link the climate timescales as like an early warning through to their more operational and weather timescale services. So there's a range of timescales. This is just an illustration to try and highlight how the capability is used to then meet these use cases. So one of the big global activities in this space for the last 15 or so years has been undertaken under the Global Framework for Climate Services. So in 2009, there was World Climate Conference 3 held here in Geneva, recognizing the growing capability from the climate science community and the growing interest from users in having that information for decision-making and policy-making. So to try and build climate service capabilities around the world under a global framework. I had the honor of being involved in this from the beginning, so I'm very pleased to be able to present this. So this was an activity that was launched in 2012 with a vision to enable society to manage better risks and opportunities arising from climate variability and climate change. And this needs to be using science-based climate information. So the information needs to be based in sound science. This framework applies for any sector, but there's some priority sectors that have been thought about right at the beginning. And these priority sectors are still key sectors around the world as we think about national adaptation plans and nationally determined contributions. So agriculture and food security, water resource management, health, particularly human health, disaster risk reduction, and then a later one was added after 2012 for energy, recognizing the growing importance of energy and climate services for energy, particularly renewable energy. The diagram on the right then shows the different components of this global framework. It's almost like a value chain or a value web, showing the key components for climate services. So starting at the bottom, the climate observations and the climate monitoring, the climate research, modeling and prediction, providing the underpinning knowledge, data, information, which is often needed. And then the next layer up is the information system. So making sure we can provide relevant information to the users at the top. And so I think Daniela will touch more on this user interface, this user engagement and co-development more. So looking forward to hearing from Daniela. So that engagement is essential to make sure that users get information that's relevant, useful, but also the providers need to understand what it is the users want so they can develop and provide relevant and useful information. So that was launched 13 years ago after several years of planning, and there's been various reviews done of progress, and there's been a lot of achievements over those 13 years, not necessarily directly because of the Global Framework for Climate Services, but certainly achievements that have happened during those years. So firstly, the awareness of climate services. I've been involved in this space since 2009. It's absolutely exploded. If we ran this webinar 10 or 15 years ago, I don't suppose there would have been so many people. So thank you all for your interest. So the awareness of climate services has been greatly elevated, and the role they play in supporting policy and development globally, regionally and nationally, including in the United Nations Framework Convention on Climate Change Conference of Parties to the Paris Agreement. So climate services do get mentioned in various COP documents. Secondly, they've helped many organisations. So from the WMO world in particular, we're very pleased that national meteorological services in many countries around the world and others are being involved in climate service development and delivery within their countries. And so a specific activity I'll come back to later is National Frameworks for Climate Services, NFCS. So this is a global framework, but things happen often at the national scale. So they're certainly helping many organisations, including national Met services, be central to climate services within their country, and these national frameworks are recognised as a key framework for supporting adaptation action. Thirdly, there have been many investments over the past, and there continue to be investments across the whole parts of the climate services value chain. And so having this framework in place has allowed many of the donors to better align their investments to other donors and be able to identify where investments are taking place and where they're needed. And there are major programs and initiatives underway as a result of those investments. But as I say, that continues to happen. And so there's an increase in these activities and the financing. And so this continues to need coordination so we can align those efforts as best as possible, and we can avoid piecemeal and isolated activities and overlapping investments as much as possible. Next, the global framework is now embedded in many regional and national programs and activities. Many donors would make reference to this global framework to make sure that activities are aligned to this and aligned with other activities around the world. And then finally, I don't know if this is good news or bad news, but climate services, they're even more important and relevant now than back at World Climate Conference 3 in 2009. We continue to see the climate change. We continue to see important developments. And so the role of climate services is growing. So through these reviews and studies of the global framework, we've been thinking about what to carry on with into the future. So I joined the WMO 2.5 years ago. So I've spent quite a lot of time in my role thinking about the future of the global framework. So we're refocusing it on these 5 broad areas, which I'll go through quickly now. So firstly, key activity to strengthen the climate service capacity and capability of ideally all of the actors in the climate service landscape, but particularly the national Met services and other key organisations, so that we can improve the availability, access and use of climate information and provide scientific and technical support. And then through establishing national frameworks for climate services, so national coordination, we can help actually strengthen the capacity and capability in all of the countries. Secondly, looking to support climate policy and finance with authoritative scientific information. So there are a range of reports provided around the world, including from WMO, to support adaptation and mitigation. So I'll touch on some of those shortly. Thirdly, looking to develop standards, quality management and training for climate services to improve the capabilities and capacities of all of the organisations involved in this around the world, and looking to produce guidance on standards and competencies. Fourthly, all parts of the climate services value chain need developing. There's the figure down the bottom left as a repeat of the figure on the previous slide. So we need to keep improving the climate observations and monitoring, the research, modelling and prediction, the information, the engagement with the users. All parts of this need improving along with capacity development. And then finally, make sure that we can coordinate globally, regionally and nationally, because climate services are essential for so many parts of society. So some of the specific activities that are underway. So some of you may be familiar with regional climate outlook forums. So there are many of these regional climate outlook forums take place around the world. The map shows the regions that are covered. Some of these have been going since the 1990s. Some are more recent. And these are proving, or have proven, very successful for bringing different groups together. In this case, with the Regional Climate Outlook Forums, to produce a consensus-based seasonal climate forecast for that region. So bring the seasonal forecasters together, produce a consensus seasonal forecast for that region, and then engage with decision makers in that region to develop and disseminate that forecast. However, probably of more interest to this group, there are many regions and many users who are interested in timescales beyond seasonal. So we're looking to transition to regional climate forums. So depending on the needs in a particular region, there may be interest in climate change projections in that region, or sub-seasonal predictions, or climate monitoring. And so we're evolving these regional climate outlook fora to be more broad depending on the needs in that region. Regional climate outlook forums will definitely exist. There's a huge interest in seasonal information in many regions, but we're now expanding this to cover other timescales. And at the national level, so back to the national frameworks, so we're working with as many nations as we can around the world to support development of their national frameworks for climate services, to support coordination, governance and collaboration at the national level, ultimately to improve the development, delivery and use of climate services at the country to support decision making. So that's happening in various countries around the world. And then when a country has this national coordination mechanism, we very much support using that as a place to have a platform for dialogue, a national climate forum, so they can design and tailor climate information for their own specific national context and translate key climate messages for users within that country. And so The figure here is a snapshot of national climate report that took place back in 2024, I think it was. So quickly moving on to some of the products. So the WMO has various climate reports it produces. So these are illustrated on the slides here. I suspect we can make these slides available after the webinar. So jumping to perhaps our key one. So every year we produce an update on the state of the global climate. So we've been doing this since 1993. We submit this to the United Nations Framework Convention on Climate Change COP meetings. We've been doing that since 2016. And this very much complements IPCC's longer term assessment cycle. So IPCC assessment reports typically come out every 5 to 9 years. It varies depending on the assessment cycle we're in. 9 years is a very long time to wait. 5 years is a fairly long time to wait. So these reports provide an annual update of observed long-term trends of key climate indicators. We summarize some observed climate variability and some drivers of that climate variability. We list some high impact events that took place in that year and some socio-economic impacts. And then over the last few years, we've also been doing regional state of the climate reports. The first one was for Africa. I think that started in 2019. And then we do one for Asia, one for Latin America and the Caribbean, one for the Southwest Pacific, and then more recently, one for Europe with ECNWF's Copernicus Climate Change Service. So perhaps the key headline that comes out of these State of the Climate reports, particularly the State of the Global Climate Report, so this was launched in March of this year, is the figure on the right. So this shows the time series based on 6 observational-based data sets of the global mean near-surface temperature. 3 of the data sets going back to 1850, and then they run through to present day, so to 2024 in this report. So the headline from the report for 2024 was the warmest year on record, 1.55 plus or minus 0.13 degrees C above the 1850 to 1900 baseline. And so this is the sort of information we provide to COP, to various UN agencies, to Met services, to whoever it's interested around the world. So we also report on the state of climate services. So this is an example from 2023, where we summarize the state of climate services for the health sector. And so the headlines from this one, so extreme heat causes the greatest mortality of all extreme weather. We often see images of floods, droughts, but it's actually heat. It's often called the silent killer. So extreme heat causes the greatest mortality of all extreme weather, with some rather scary numbers, an estimated 489,000 yearly heat-related deaths globally over that 20-year period, 45% of those in Asia, 36% in Europe. And heatwave mortality, it's very hard to get these figures, and so the numbers could be 30 times higher than are actually recorded. So back in 2023, we reported that heat warnings are only provided in half of the world's countries, and only 26 countries have climate-informed heat health early warning systems. So we've been working a lot over the last few years to improve this. And this very much aligns with the UN Secretary General with this early warning for all initiative to have everyone on Earth protected by early warning systems by 2027. And so we're seeing great progress here, and the importance highlighted in the orange words that early warnings and climate services are vital to protect communities and economies, for example, for heat waves, but there are many, many other examples. And then my final example will be for the energy sector. So this is a report we'll be launching hopefully next month, along with Irina, to give a review from 2024 of the climate-driven global renewable energy potential resources and energy demand. So looking at wind power, solar power, hydropower, and energy demand. So look out for this report next month, but you can look back at the last year's report. So this was done in 2022 and 2023 to give some information about renewable energy. So I think this is my final slide, Henry. I'm not sure how I'm doing on time. So just to quickly highlight some future challenges, which we might come to in the Q&A, but there are many melon challenges, but here's just a few. So how do the providers of the climate services deal with the growing user interest and demands? Clearly, providers want to have interest and demand for their services, but it is a real challenge. And as well as the growing demand, there's challenges around what's being asked for, more information, reduced uncertainty, more spatial detail, whatever it might be. Secondly, on the other side, how do the users navigate the growing number and variety of climate service providers? So there are many, many providers nationally, regionally, globally. There are public sector providers, there are private sector providers. So it's quite challenging for the users to navigate this landscape. Linked to both of the above is, do we need standards for climate services? It's tempting to say yes, but if so, how do we do that? What would we do? And who would we do it? So there are many activities, particularly in Europe. So some of us have just come off another meeting looking at standards in Europe under the Climate Europe 2 project funded by the European Commission. And so this is a topic that's being actively thought about. And then finally, what is the role of AI and machine learning? I don't know the answer to that question, but I'd be delighted to have discussions around that in Q&A. So thank you very much for listening, and I'll end there, Henry.
Great. That was a great overview from Professor Hewitt. Just for the audience members that showed up a little late, we do have a written Q&A enabled on the bottom in the box. You can type in your questions, and we will also have an interactive question and answer session after all the presentations. And then you can raise your hand and we will allow the microphones to be open. So for our up next, we have Professor Ogunjobi, who has been the Director of Research at the WASCAL Competence Center since 2020. And under his leadership, the center has fostered collaborations with universities, research institutions, and governmental bodies, creating network for knowledge exchange and capacity building. So we thank Professor Ogunjobi for joining us today and giving us his time. So now we turn our attention over to you.
Okay, thank you so very much, Henry. Can you hear me, please?
Yes.
Yes, thank you so very much. And it's a pleasure to be here from WASCAL. Like you said, WASCAL is the West African Science Service Center for Climate Change and Adapted Land Use. We have our headquarters in Accra in Ghana, while our research and climate services center is there in Ouagadougou in Burkina Faso. So I'm seated in Burkina Faso, right here presenting to you. It's a delight to be in this webinar once more. And I want to acknowledge that my presentation is a conglomeration of work in a team called the climate service team, called the Circles. And I want to acknowledge my colleague, Dr. Seni Salak, Dr. Safia Tusamfo, and the entire team. We also want to acknowledge GERICS, whom we are working together, and I'm happy that Professor Daniela Jacobs is here. Thank you for the fantastic collaboration with WASCAL. And I believe the two institutions, we are making progress within our region. My slide, is it moving to the next slide? I'm on the outline. Can you see it, Henry? Is it moving? Yes. I've outlined my presentation into two sides. One, to define climate services, its pillar categories, and then the characteristics. Then, more importantly, I want to dwell on hands-on information that we are doing together with GERICS in our region. And I think this is really going to be very interesting to our participants. And again, I think Chris has laid good foundation, but we want to really see hands-on information from Circles and how WASCAL and GERICS has been developing climate services, for the use of policymaker end users, and definitely to increase livelihood in our region. So I will first start. I think Chris has well defined climate services, which according to WMO, and we appreciate you for defining this. And I just picked this from the WMO definition, that is climate services are the provision and use of climate data, information, and knowledge to assist decision making. However, I got a much simpler definition. Of course, WMO, we know that you are the authority here, but I got a more simpler definition, which says climate services refers to a system or a process that translates climate data, scientific knowledge, into tailored information. I think the word tailored, it's really very important for us there. tailored information, product, and tools. Tools are also part of services which we are developing, and which is also very important for end users to support decision-making across society. Why climate services? And we know that, of course, extreme weather events, either in Africa, in Europe, of course, is really becoming more frequent and intense. And the most likely they're expected to become more frequent and intense in West Africa, where we are seated, especially in this 21st century, according to Taylor et al. 2017. My colleague Salak et al. Is a work we did together, Salak et al. 2018. Of course, Africa is seen to be very particularly vulnerable to extreme weather climate. We have series of events, 1997 event, 2009, 2010, 2019, 2020, just to mention a few across our region. Rainfall is seen to be more than 10 times above normal, which have caused flood in Niger, in Burkina Faso, Mali, and Cote d'Ivoire. And this actually necessitated us to begin to look inward and do services in order to ameliorate and reduce the impact of this severe weather impact. Now, I want to show you in terms of magnitude. And here, I'm looking at on the right side of the screen, you see the different categories, especially in the Sahel. And we have divided the Sahel into the Northern Sahel, the Southern Sahel, and then the Western Sahel. And you see the impact of high extreme rainfall in recent times this is average between 1960 to 19, seeing that we are beginning to see increase in the frequency of extreme rainfall. At the left side corner of the slide, you also see the location and timing of first onset of rainfall, which is also very important in agricultural sector, in our region. And looking at that, you will see in the Sahel North, the frequency of first onset has seen to be increased between 25 to 31 occurrences in terms of frequency. When you see the Central Sahel, which is the light blue, also between 19 to 24 in category 2, while in category 3, the first onset is between 13 to 18. So this frequency is becoming really very rampant, and it has a lot of significant effect on our agricultural sector. I think Chris have shown this slide, but I just want to show here that, of course, all these from capacity building to information provision to users interface and user, and I believe that Daniela is going to speak more, this is more of co-creation, co-production. And this is essentially how our cycles, how our climate services in WASCAL are being produced. We have the producer, which is in terms of the capacity building, together with the scientists in the lab, taking observation and monitoring, and also conducting research, modeling, and forecasting. The interface union, the intermediate union, is the provision of this CS information and users interface, while our beneficiary is the user. Another important thing to take home here is that, of course, in co-production, beneficiary becomes stakeholder, and we take note of this very prominently in our process of climate services. Now, there are value chain in the production of climate services, which we also go through in WASCAL. If you see the big egg, we have seen that who are the people that are producing climate services. We have the red portion, which I call the National Hydrometeorological Services. We have the regional centers, and of course, institutions like GERICS, a global institution and organization. WASCAL, HACMAD, Agreement, ICPAC are regional institutions. Of course, Chris mentioned National Hydrological Services. But more importantly, is that all these institutions that are producing climate services we know that it is very important for us to have a legal framework. We need to have adapted tools and techniques which we are using to produce climate services. We need qualified staff, high quality work environment and cooperation. And this will lead to a more trusted, reliable, accountable, and user-friendly climate service provision. So that is just the essence of it. And moving forward, I want to say that the characteristics of the climate services that we jointly produce with GERICS are shown on this slide. And in terms of the characteristics, we believe that it must be of high resolution. 2, good accuracy. In those days, we have accuracy of 10 to 30 days for weather forecast, but now we are scaling it down to even between 1 to 7 days. And I think Chris also defined some time scales, for climate service provision. We think it should be relevant to the community, to decision making, and also to stakeholders. It should be accessible, it should be economical, it should be perishable, and then, of course, there must be some uncertainties. These are characteristics of what we think, peculiar to services. Now, I want to now go to the specifics now. I will quickly run over this in the next 6 minutes. The climate services as produced by WASCAL and supported by GERICS. And I'm very proud to continue to put GERICS, and we are really very grateful to this collaboration between WASCAL and GERICS. This is the customized and integrated climate services for improved resilience and sustainable socioeconomic development in West Africa, called CIRCLES. Well, different pronunciation or nomenclature for the CIRCLES. Some people say it's CIRCLES, some people say it's CIRCLES. So, well, depending on what you want to call it, but we say it's CIRCLES, in WASCAL. And we have defined it combining my 2 definitions. And we said CIRCLES is defined at WASCAL, and I want to repeat it at WASCAL, peculiar to WASCAL, as services that are operationalized provision of customized and integrated climate and environmental information, engineering solution, policy guidance, and knowledge to support resilience, sustainable development, and improve livelihoods in our countries. This has been acceptable according to the publication of Sanfo et al. 2022. There are 5 portfolios in our circles in WASCAL. The first portfolio is what we call the data storage and computing, DSC, timely information on extreme climate, migration, and natural hazards, climate policy and action, and then scientific exchange, training, and vocational courses. Those are the 5 portfolios of services that we are partnering with GERICS to develop. And we are using this in a goal to support sustainable development and improving livelihood in our region. The operationalization scheme for CIRCLES is, of course, immersive co-production, customized delivery, public dissemination, and then evaluation of feedback and uptakes from the end users. We started this project on 1st of August 2023. Let me quickly go through some of the activities that we have done. Number 1, we have provided services through text beds and through demonstrations and pilot sites across the entire landscape of the region, as you have seen in this slide. And we have collected data, we are testing prototypes, we are disseminating information, we are co-producing, and we have feedback. The beauty of it is that CIRCLES has its footprint across all the 15 member countries of ECOWAS. Okay, let me not use the word ECOWAS because ECOWAS now has some political implication. I will use across West Africa. In terms of some of the deliveries, I said we have been delivering information through CIRCLES using Climate Fit School by users' engagement, participatory observation, deployment of even what we call the Plant Sane app, which means where we develop an app to monitor pests and diseases in 3 major crops in Burkina Faso: tomatoes, onions, and maize. We have also, in terms of support to climate policy action, you remember I said there are 5 pillars. One of it is climate policy actions. We are also an independent, we are also participating in the Independent Global Stocktake, IGST, where we have been helping countries to develop and update their national determined contribution. These are some of the activities that we are doing in terms of climate policy and action through the Circles project. And we are looking at this in a non-state actors aspects, not the state, but the non-state actors. And this is one of the very typical aspect that we have contributed to the UNFCCC information. We have participated in global platforms like COP28, COP29, etc. In terms of climate action, also we participate in terms of Network of Africa. We have organized training in multi-hazard and early system in Ghana. I've seen here in slide number 17 here, we have organized training. We have organized tabletop exercises, and then in terms of timely and customized information, we have also produced policy briefs where we have projected rate of change of precipitation, temperature, water runoff, soil moisture, as shown in the first slide. We have also developed a flood and drought risk map for the WAD districts in Ghana. Above that, we have projected changes over the national park in Guinea, where we have also produced a timely and customized information, for users over there. We have contributed also to identify vulnerable areas of flood, also in Ouagadougou, in Burkina Faso here, which we have handed over to the municipal, in the city. So these are some of another one that is really very interesting to me is that we have also produced what we call the multi-hazard map for West Africa. This we have done also by looking into river flood, coastal flood, urban flood, drought, landslide, wildfire, etc., and etc. And we have discovered that all countries are at high risk of at least one hazard or the other in West Africa. And that is coastal region or coastal countries, of Nigeria, Sierra Leone, and Liberia are also of high risk to landslide. This we have produced in policy briefs, and then we have distributed to various countries, to our partners, that are in need of this information. Just a few more slides. In terms of also timely and customized information, I so much love this slide. Is one of also delivery that we have done for the region. Is we are trying to prepare the readiness and capacity of West African countries on how to deal with climate change and disaster reduction, taking note of different indices. And if you see the last bottom bar, you will see that most of the countries in West Africa are only moderately prepared. Luckily, we didn't have the red one to show that our countries are not readily prepared, but most countries are moderately prepared, with Benin, Cote d'Ivoire, Guinea-Bissau, and Togo having high preparation levels for. And this, we have prepared it also in policy briefs and also in opinion papers. More in terms of multi-hazard, we are also participating in the Network of Excellence. We have, like I said, we developed a tool called the Plant Sane, which we have used for early warning system for pests and diseases in 3 crops in Burkina Faso. This app is available for use, online. It's also on the Google app. We have also supporting the meteorological agencies in terms of their data, and the hydrological agencies in terms of their data across the region. Of course, we have delivered on and off-season agroclimatology information, timely delivered. We are still working on this package in order to have it translated to three languages. These are what we have been doing. In terms of vocational training, which is the last slide, Henry, I know that you were almost trying to stop me. This is the last slide. We are also participating in vocational training together with the team of Daniela, and we are very, very grateful to this. We have organized one summer school called the WASCAL GERICS School. We are planning for the second school. 350 people registered. About 35 was physically present here in Competence Center. We have been training staff of hydrometeorological services. Currently, as I'm speaking with you, the staff of the Gambia Hydro Services are with us, where we are training on the use of hydrological equipment. We have a very fantastic GI lab. We have a computing facility, which we have also formed community of users around this facility in the Competence Center as a way of services. Let me just conclude that, of course, climate services are no longer optional. They are essential tools for resilience, policy, and progress in Africa. Through Circles, WASCAL is delivering timely, customized, and integrated solutions. And we believe that the future for climate resilience in West Africa is through collaborative, data-informed, and people-centric. And this is what we are doing, and we are really very grateful to participate here this afternoon. Thank you so very much. I yield the floor back to you. I apologize. I spent some few minutes above the time. Thank you.
Great, thank you. That was a great overview of WASCAL and the Cycles project from Professor Ogunjobi. Our final panelist today is Professor Daniela Jakob, Director of the Climate Service Center Germany. Professor Jakob has been the Director of GERICS, an institution of the Helmholtz-Zentrum Herion, since 2015. She's a professor at Leuphana University Lüneburg and was a lead author of the IPCC Fifth Assessment Report WG2 and the coordinating lead author of the IPCC Special Report on the impacts of global warming of 1.5 degrees above pre-industrial levels. She currently chairs the Climate Council of the City of Hamburg and the German Committee for Sustainability Research in Future Earth. We thank Professor Jakob for giving us her time today. We now turn our attention over to you, and the screens are yours.
Hello, can you hear me and
Yes.
see my slide, Henry? Very good. So first of all, let me welcome all of you also from my side. I'm very pleased to have so many participants in this webinar, in this INBOA webinar. I do think the climate services are of utmost importance for the next decades for all of us. And I'm very pleased that Chris Hewitt and Professor Kehinde Ogunjobi were joining me here as panelists and as speakers. So the two presentations very nicely showed and gave you an overview of the global setting and how important hydrometeorological data are, but that they are not all of it. The importance is how to work with the data and how to connect the climate data, let me put it this way, with the non-climatic data. So let me talk a little bit, why is this so important? I would like to give to you two readings. I'm sure you know them already, but let me step back for a moment. I do think here this one paper by Tim Lenton called Quantifying the Human Cost of Global Warming is one of the important papers in 2023, which gives us a warning and gives us also a little bit an impression about the future. So climate change has already put about 10% of the people out of the human climate niche. What is a human climate niche? It is, of course, a temperature range. If it's too cold, people die, and if it's too warm, people will also die. And we cannot protect ourselves globally everywhere, every moment with heating and cooling systems. So we have to think a little bit about what are we doing with the global distribution of habitable areas. And he assessed with his colleagues that by the end of this century, if you continue the emission release as we do at the moment, so that we end up by a global warming by the end of the century of about 2.7 or 3 degrees above pre-industrial values, maybe something between 20 to 40% of all people globally have to be put out of their temperature niche. So this is alarming, but there is hope, and that is that mitigating climate change, and that's why it is so important, can help here and can reduce this number to about 4 to 10%. So I really recommend to you reading this paper, because I think it is an eye-opener. The second eye-opener is here, this figure, which is my favorite figure, and I'm pretty sure most of you know this. It's from the IPCC AR6 synthesis report, and it shows you where and how your children and your grandchildren might be exposed to global warming. It's a similar figure as we see very often. It is the difference of the global mean air temperature. It's about 2 meters above ground, and Chris knows everything about it, and WMO is so important in measuring all these and taking control. It is a deviation again for the pre-industrial time period. The more red it is, the more warm it is. And you can see here from 2020, now we are at 2025, but from 2020 onwards are the so-called future emission scenarios. And the lower one is the one which is in line with the IPCC lowest scenario, but also with the Paris Agreement, keeping warming around 1.5 or 2 degrees. On the upper right corner, the more highest, and purple is global warming goes beyond 3, 4, 5 degrees. And if you now look when you have been born, or maybe when your children might be born in the future, you can see that during a lifetime, we are now exposed individually to a much stronger warming than the generations before. Or, for example, me, I was born around 1960. So I had the first 3, 4 decades in a relatively stable climate, which I could really build some confidence on, some trust on, and some mutual resilience. If we are now not only exposed to fast changes in climate, but also in many other technology changes, crisis, multi-crisis, it can be shown that the mental health is being affected. So it's very important to have this in mind. And how to cope with this is, of course, to look at climate services, and climate services are means to be better prepared of what might be ahead of us. We were heavily involved in the definition of the climate services roadmap, I would say, and we saw some definitions before. We still use the definition which has been worked out in the European context for the European Research and Innovation Roadmap for Climate Services. And it really says here, adaptation is place and context specific, with no single approach for reducing risk appropriate across all settings. This is really important. It's from 2014, and it's still true. And we saw this very nicely in the 2 presentations before. In addition, then now since 2015, we do have the Journal of Climate Services, which we initiated with the publisher Elsevier. And in this journal, we have now many issues here, volumes here. We have not only scientific papers with a paragraph about the practical implication of the new scientific findings, but we also have case study knowledge which we gained, which can be transferred and shared to others. So please have a look at this. I'm very, very happy that we have this dedicated special journal here for sharing our expertise. What also has happened in the past and until now is that climate services are still used, and the wording is still used for two different meanings. Partly it is used for the meaning there is an institution, a climate service provider. And there are several types of providers. As you can see here, we heard about the National Meteorological Services. We have some multidisciplinary public climate services, but also private businesses has picked up here. And we have, at least only in Europe, more than 400 climate service providers. Only in Europe. And climate service providers, public and private, have been grown all over the world. So you see it's a growing market also for you to go in and to support a sustainable and climate resilient lifestyle. The second way how the word climate service is used, it's as climate service products. So we have to be very clear when we talk. Do we talk about climate service institutions providing climate service information or climate service products? And climate services can then be categorized in different categories. For example, climate service products which heavily rely on climate simulations and data. And Chris mentioned the Codex initiative, which is a coordinated downscaling experiment of the WMO WCRP initiative, which I would say bridges the gap between the global climate change characteristics and the local features on the ground. So here you see an example for what we are currently doing. We are using large ensemble globally, as you see here, this little globe. Then the Codex, the coordinated downscaling activities focusing on all continents and parts of continents and Africa. And that's why it's so nice also to have today a focus on Africa here, was one of the main continental regions where we worked on coordinated in the climate simulation and science community. But it goes further down to cities and vulnerable areas. Of course, all these products can also be sectorially oriented, and we saw this in Chris and also in Kehinde Ogunjobi's presentation. They need a spatial coverage, but they are non-uniform. They are non-seamless, and they have to be fit for the individual purpose, which we could very nicely see in the last presentation with the WASCAL specific examples, how important it is to bring in your cultural knowledge, your regional knowledge, your experience of the practitioners in the region, in the sector you're working with. And as I said now, it is also a developing market. Consultancies, public-private partnerships are important, but this also means costs, but it also means we have to discuss about standards, as we heard before, because I do think we need a minimum of understanding ourselves if a climate service product is trustful. Can we build a decision on it, or can we not build a decision on it? So this is why co-production of climate services is so important. Co-production processes are functioning in a way that I would say scientific climate knowledge providers jointly work with practitioners, with stakeholders of different sectors in different settings, and jointly develop in a consultation process a climate service product which really is fit for the purpose. So the co-production process goes far beyond the consultation phase, where you could say, let's talk a little bit, and then the scientist or the practitioners goes home and is doing whatever they like. It is an iterative, sustained process to build a trustful relationship, to enable practitioners, communities to do their own climate services, to carry out what's needed for their purpose, for their business. It is a capacity building process, but it is, I think it's of utmost importance that it is a shared understanding of the problem to be tackled. So if we talk about regional climate resilience, it is the connection of the mitigation, the mitigating emissions, mitigation of global warming, and the adaptation to the impacts of the changes which we already see or will see in the future, to develop the joint understanding to maximize our resilience and to develop jointly the capacity so that the entire global population is lifted up to a more resilient level. So this takes place across researchers, practitioners, and so on. It requires, of course, that we listen to each other, that we respect each other. So it requires transdisciplinary competences. It reaches out to both public and private sectors, and it includes citizens and the entire society. So what's needed is an early and continuous engagement of all stakeholders and building trust. And this takes time. But it is as it is. This is where we jointly can get forward. It customizes the services to the user's circumstances. We learn, of course, from best practices and establish institutional arrangements, which we need. We cannot always start at point zero again and develop the same thing twice or three times or four times. We have to share what we can share, transfer what we can transfer. So, and it needs a joint understanding. So let me bring you to this role of the boundary institutions. I do think it's important in this role of co-production of climate services to understand that yes, there are uncertainties embedded, but uncertainties are everywhere in our life. Everything is uncertain. It's fully unclear what's happening in the future. Some things are a bit more certain than others, but so uncertainties are not unusual. It's normal. So we have to deal with things we might anticipate, but we do not finally know. It's not an excuse to not act. It's not an excuse for not acting that you have uncertainties. But we also need a dramatic acceleration to enable the broad co-development of climate services. And I'm very happy that we have also university collaborators here, because I do think it has to enter this understanding of weather and climate is on our day-to-day life everywhere, to bring this in the educational levels, into the schools, into the university settings, and also enabling citizens to understand and be part of the endeavor to build resilience. So, and this is where I think the boundary institutions can help a lot. There are a lot of key findings, I will jump over them for a moment. Let me give you a few examples here. I think it's important that we understand where we are in the process. And here you see how GERICS actually is working, with the Climate Service Center I'm currently leading. So we always think first, where are we in this consultation process? Do we just want to give an information? This could be a book or a paper or a map. And do we just want to pass our knowledge to someone else? Or are we interested in the requirements, the needs of stakeholders, of communities? Are we in the consultation process? And depending on where we are, the level of engagement is different. After, I would say the next level of engagement is a dialogue. Let's jointly talk. Let's talk about the problem. Let's talk about what would be needed. How can we go forward? And let's talk about the joint endeavors, which then hopefully end up in a partnership where we work together, where we jointly develop a fit-for-purpose climate service product, which is useful and which can be used. And then it will also be used. And for all these stages, you can see, at least that's what we are doing, we have different styles of products, which you can, of course, take and transfer to your own settings. So the enabling of communities globally is very important for us. Let me give you an example here for tourism, coastal tourism and beach management, for example, where exactly we went through this stepwise procedure where we initiated the contact, listened to the coastal stakeholders, and established a trustful cooperation. So that is absolutely needed. We both want to do something jointly so that we benefit jointly from it. Then the identification of the problem started, and you can see this here. Now we developed a collaborative map, the visioning was being done, then the co-production of the solution is being done, and then it's on the stakeholder side to implement the solution. So the climate service is accompanying you, I would say, from the beginning towards the solution-oriented new knowledge which has been generated, but the implementation, of course, that is in the hands of the local society, the decision-making, the local policy-driven agenda. This, of course, also works when you look into companies. So the companies can be enabled, and we heard about, I think it was Chris saying, about the value chain, about hazards in one part of the globe where the production of your material, for example, or your food is being done, and then how this has an impact in other areas of the world. So if you look at companies, it's important to connect the knowledge of the climate science in a way that the private business can work itself towards a more resilient setting. So integrating climate information into business strategies is of importance, and there are, of course, guiding principles how to do this. We call it implementation frame, because we would like to enable the business, to enable the company to do it on their own, and then build on the data which is available through the National Weather Services, through the GFCS, through what WASCAL is showing, and many others. So there are tools. You can also transfer this to the cities, and then I'm almost done. So what we have done is we have built a modular system which we can transfer from one city to the other and look at the specific needs of a city. The specific needs could be related to urban water. It could also be related to critical infrastructure, or they need specific information for the transport sector. It could be connected to the well-being. So it's important to first understand, as I said before, where is the problem, and that's what we have in co-designing what we need. It's the same for everything. Is the generated climate information must be usable. So it can be useful when it is co-designed. It's much easier that it is usable when it is connected to, for example, practice theories. And then this does not mean it will be used directly, but if it is fit into a usability framework, so it is introduced through norms, through practices, it is anchored in the let's say here it is the administrative processes, then we have generated a workflow that climate information is mainstreamed into day-to-day practices. And I think that is what we all have to try to go for. One of the last slides here is now geared to the more scientific-oriented audience in this webinar here. I do think it's not only the joint development and the connection of the practitioner's knowledge and the scientific knowledge for the individual purpose. There's also room for development of new information and scientific results and scientific knowledge. So if we look here, for example, we did a literature review, which is a standard what you do first. Then you build on your question theory and concepts. This could be a toolbox following what I just showed you for the cities. Then this can be connected with your modeling framework. And here the modeling is not only the physical modeling or the hydrometeorological modeling. I think it's really important here to also reach out to the new AI tools and to connect the non-climatic modeling like demographic changes, flow of goods, transport modeling, decision-making modeling with the climate knowledge and the climate drivers. And this can then all goes into support for policy making and decision taking. So I think this is more or less what I wanted to share with you for today, and I'm very glad now to listen to your questions, and I hope I can answer some. Thank you very much.
Thank you, Professor Jaco, for the insight on climate service and co-production. We will now open the floor to your questions from the audience. So please feel free to drop them in the Q&A box or raise your hand, and we will do our best to get through as many as possible. So we actually have a few questions that hasn't been answered in the Q&A box that I will just kind of read them off, and I think perhaps one of the panelists will be able to answer. The first question is, do the climate services economic efficiency to the rural poor? So I believe it's saying, are climate services economically efficient or perhaps beneficial for the rural poor? That's one question. And it's similar, is how do marginal groups in society access climate service? Does anybody want to take this question from Chris or Daniela or Kehinde?
Yes, I can share an experience. Yeah, let me quickly share an experience with the questionnaire. For example, we are WASCAL, which I was actually involved, a typical, live experience. And it was about one of the slide that I showed where WASCAL is providing climate service information remotely through Android phone to end users or farmer in the farm some 30, 40 kilometers away from the Competence Center. And what we discovered, I paid a visit, a live story like this, I'm telling you. I paid a visit to these farmers, to the group of farmers. We have about 250 of them, which we distributed this. And then we are passing information, live information, as we are, getting results from our model results on time of planting, type of crops to be planted, time to irrigate their farms, time to harvest. And I paid a visit. And after paying the visit, they told me that though it was difficult for them to adopt our services through indigenous knowledge transfer, in this part of the world, our farmers still believed in the 1960s, 1950s method. But when you want to introduce services with high-tech development to them, they find it difficult. But then we have 2, 3, 4, 5 farmers that came and shared their experience that by these climate services that we have developed and share with them regularly, they have increased their crop yield from a certain hectare, and they were able to sell, take care of their family, educate their children. That has never been like that before. So in summary, Henry, I think WASCAL is the living testament that farmers, end users, has convinced us, has returned back with testimony that services actually improved their productivity. Let me stop there so that other members can also respond.
Great. We'll move on to the next question. I've jumped down here to the question for Chris about the biggest challenges in ensuring national meteorological and hydrological services remaining central to climate service delivery, having this progress in embedding climate services at the national, regional levels.
Yeah, it's a good question. So that'll very much depend on the context and the country and the Met service, I should think. But examples would be perhaps even awareness of what the Met service provides in terms of climate services and weather services, but climate services. So many decision makers in the country may be unaware that the National Meteorological and Hydrological Service has information that's relevant to them. So that is a big challenge. Funding is always a challenge. We will need resources to develop and deliver climate services. What else would there be? It would be very much dependent on the country, but I should think, yes, awareness of what the Met Service can provide. One of the reasons that we're pushing the idea of national frameworks for climate services, the coordination, is so that you can bring all the different groups together within a country so they can collaborate effectively, and that then helps raise the awareness of each of the individual organizations as well, and hopefully you then develop, deliver and use climate information better and more effectively So I don't think there's one answer to that question, but resources, awareness, capabilities, capacities, those sort of things are typically a challenge for many countries, if not all countries, actually.
Great. That's a great answer. I think a follow-up to that really is how do scientists incorporate indigenous climate knowledge to scientific climate service? I think that's a question for all three panelists. If Daniela wants to go first.
So, sorry, I was just typing an answer to one of the
Sorry.
questions. Can someone else go first?
Sure.
Sorry.
So how do scientists incorporate indigenous climate knowledge? Or Kenny or Chris?
Can I come in? Just to share also, I've always come with experiences. Yeah, I think the way we have done this in WASCAL is what the three presentation dwells about. In the process of co-designing, we invite, all stakeholders, farmers, end users, extension workers, health workers. In fact, I can tell you that sometimes even for cross-border migration, we brought in immigration officers, immigration officers to come and partake, in the development of services with us at the Competence Center. And when they come, Henry, it will surprise you that you will learn much more from these indigenous end users, because they will come, they will open up to you what are the traditional methods that they have been using. So we interact with them, we co-produce, we co-design, we co-produce all our services with this local society or local group or local end users or stakeholders. We bring them here to the Competence Center. We have 2-3 days brainstorming. We gather their ideas together and then we incorporate it in our model, before, getting our services developed. And this is what we have been doing with GERICS over the time, So it is very important to co-produce with those end users who has that local knowledge. Yeah.
That's a great answer from Kenny. I can't improve that answer. It's absolutely right. Yes. So in terms of, it's not just the indigenous knowledge for the science, it's also the engagement and the communication and all of these things. So
Absolutely.
Yeah, the question was about the science, but Kenny's answer was even better.
Maybe I can come here and pick up one of the questions in the Q&A, which is slightly related, and that's about the different languages and the political and cultural context. I do think it is important to try to engage as many of the native speakers in the regions where you're dealing with. So I think it's not so good to develop a climate service product here and then transfer to somewhere else without having the transformation and the translation of the product into the specific context of the region you want to transfer to or the sector. So, and that is in language, which means you might have to translate it into very, very regional languages. And that's why we try to also get funding for this, so that with this translation and with the cooperation with the local community on the ground and the reach out to their specific knowledge, which you cannot read somewhere, which is in the dialogue. I think it is not only providing, or we are not only providing climate services, but we also support capacity development and exchange cultural knowledge. So, and there's one question here talking about the climate service products developed on socioeconomic, political, and cultural context. Yes, they are not all of them. Some are, I would say, some climate service products are mainly number crunching, which are more, I would say, on the data information side. But as soon as it gets into the guidance and framework and into the applicability and the development of of fit-for-purpose products, the socioeconomic and political cultural context has to be taken into account. But that, of course, is changing in time and region, and that makes it quite difficult to come up with one answer. So I think what is common to all of us is the knowledge from the past. And I think it's important to take into account the knowledge from the past and connect this with our knowledge about the possible future. And I think that helps to connect through the socio-economic, socio-cultural and context, and also includes more the citizen level. So maybe I'm not answering this question in writing anymore. I hope that's okay here for the person. So.
Great.
There's a question, Henry, from Ngozi Eunice Osadebe from Nigeria. Please, if you allow me, being a Nigerian too. Thank you very much, Ngozi. I think you want to know how is your publications on climate services being circulated to end users in Nigeria? Fantastic question. And the answer right now, Ngozi, I must confess to you, in all the services being developed with GERICS, we are still not yet, we have not done any work in Nigeria. Most of the work we are concentrating now, it's in the Sahel of West Africa. And I believe Professor Daniela Jacob is here. We need more funds, to conduct across the entire landscape of West Africa. But in other countries that we have developed, I think what we have used to communicate is actually, we develop policy briefs, we develop policy papers, we interact with the end users to come and uptake our information. In terms of communication, I think Daniela mentioned it. We try to see how to translate all the results from DY/DX in the science and the lab to a usable language that people understand. Your farmers don't understand what your model result is. They don't understand your DY/DX. All they understand is that what will happen to their crop if there is the extreme rainfall, and they want it in a language they understand. So we try to translate it into different languages. So those are some of the methods we have been using, Ngozi, if I'm right, to translate some of our results in the Sahel of West Africa. And I believe by the time we get to Nigeria, we will continue to adopt these processes. And then, yeah. Thank you very much. Yes.
Great. We have a question here from Lizzie. What is our plan to deliver country-based climate action for carbon market? I don't know who's this is addressed to. Would one of the panelists like to answer that? Or if Lizzie is still online, you want to open your mic and add more to your question. Okay.
So maybe I can I can give it a try, but this is a very difficult question. And I think it is also a question which I'm personally not an expert for. So because it is exactly the connection of climate services for climate resilient development, and mainly of what we have had in our experience and what we talked about today were climate services to adapt to the impact of climate change. We have not talked much today about climate services to mitigate climate change. If it now comes to the climate action for carbon market, I think we have to look into the carbon cycle, and we have to look into the questions of carbon dioxide removal, CCS, and carbon storage and use, and so on. So we have to look into the entire cycle of carbon. And in each of these, we have both two parts to look at. One is how is this production part, for example, contributing to emissions? So is it or can it contribute to less emissions? Is it a mitigation part? And or how is this part of the cycle being affected and vulnerable to climatic changes, meaning weather type changes? Both need to be considered. So if we now look into climate action for carbon market on country-based, we have to see, are we talking about carbon sinks in a way that we have afforestation options? So can we look into natural solutions for withdrawing or storing carbon? And with this, we are extracting carbon from the atmosphere, and we might get, depending on the COP negotiations, might get a fee for this. And or are we looking at techniques, or let's say vulnerable areas to destroy our sources, our sinks for carbon? So it's a very delicate question where I would say in many of the steps which are connected in such a climate action for a country, for this carbon market, are places where climate services can feed in. But you cannot just say you need this or this climate service. I think it has to be disentangled, and then has to be looked at as from a mitigation side and from the vulnerability side. And but it's a really good question. So thank you very much.
I believe we have time for one more question, and I think I would like one of the panelists to answer the question from Haman. How do climate service providers manage the socio-cultural resistance on the ground with the farmer? So it says African ground, but I think it's relevant for all cultures, sort of the socio-cultural resistance to change. We only have 2 minutes. Kenny or Chris?
If I can take 30 seconds. From the experience of WASCAL, of course, change is what is very difficult among people, especially when you are dealing with mid-class people. So what we do, the way to which I think we can manage the socio-cultural resistance is to continue to engage with them, and then show the positive sides of the services we are providing. I believe the moment they can see the results from what services we are providing, cultural resistance, knowledge, indigenous knowledge resistance, I believe this one will be limited. Let me stop there. Maybe other partner wants to come in. Yeah.
Yeah, so building on that, so that's exactly that. That's right. And the other side of this is that we are seeing some successes, maybe trying to end on a slightly positive note. So there are, of course, we need to try and overcome these resistances, understand them, especially if they're social and cultural. And this thing goes back to Daniela's point, you need to spend time engaging, co-develop, understand. All of these things take time. But we are seeing successes, particularly in agriculture with farmers. So there are successes all around the world, in Africa and other places as well. So this is a positive thing, but I'm not undermining the question, because yes, as Kenny's just said, we definitely need to try and understand and overcome these resistances. So it's a good question, but just to be positive, we are seeing successes, particularly in agriculture.
Yeah.
Great. Thanks to everyone who submitted your questions. I know we didn't get to a lot of them, but we'll try to follow up after the session, and we will email you your answers through our panelists. And so, yeah, on behalf of our entire coordination team at GERICS and INBOA with Oranos, I want to say a big thank you to our panelists for sharing your time, insights, and expertise with us today. Your contributions have truly, enriched the conversation and provided valuable perspectives for our audience. And thank you very much. I also want to thank the audience members for bringing your enthusiasm. We had over 500 signups and registrations to this topic, and it's amazing to see so many people online today. Perhaps we can build on this momentum and launch in the future another climate service related webinars together with INBOA. And we invite everyone to consult the INBOA website. Scroll up to the top of the chat box, where the recordings and presentations from this seminar will be archived and shared. And yeah, thank you very much and have a great rest of your day.